Somebody asked me to do a explanation of number 38 from 6.3. So this was from before we went to break. So I wanted to post that here. So I'm just going to go over this. The directions say evaluate the integral by interpreting it in terms of areas. So the first thing we're going to do is break this up into two integrals. So I'm going to be looking at, and this is just using properties we know for integration. This is equal to the integral from -5 to 5 of x dx minus the integral, that is a bad integral sign, the integral of -5 to 5 of root 25 minus x squared dx. So the next thing we're going to do is visualize this geometrically. So let's just look at the first one, which is the graph of x between -5 and 5. So if I sketch that in the coordinate plane, I'm just going to give myself a little coordinate plane here. And if I look at what's going on at -5 and 5, we know y equals x is just a linear function. So at -5, the output would also be -5. And at +5, the output would also be +5. And I'll just connect those. All right, so what I can then look at is that geometrically what I have here is two triangles, right? And we know that the integral represents the area between the curve and the x-axis. So up here, we have positive area. And down here, we have negative area. And since these are going to be symmetric area, I could find the area, and I'll do that for you. Right? Area of a triangle is just half base times height. So that'd be half 5 times 5, or 25 over 2. But this is all considered negative area, remember, because it's under the x-axis. So that area, since it's the same triangle but under the x-axis, is going to get us -25 over 2. And so the net area for that first one is just going to be 0. Right? Plus, so then I'll have the integral -5 to 5 of root 25 minus x squared dx. Now, this one's a little trickier, and you have to know a little bit of geometry, and some of you may remember this, some of you may not, but the equation of a circle is x squared plus y squared equals r squared. Well, let's pretend the radius is 5, then it would be equal to 25, right? If I try and solve for y there, I'm going to get, right, y squared is 25 minus x squared. And if I take the square root, I get y equals plus or minus root 25 minus x squared. And if I only look at the positive square root, that's the top half of the circle. So what we're looking at here, I'm going to sketch it out for you, is the top half of a circle, radius 5. And we know it's the top half again. Whoa, come on now. Because it's the positive square root. All right, you get the point, right? Okay. Well, all of that area is above the x-axis. So that's all positive area. So the area of a circle is pi times radius squared, but this is only a half circle, so we'll divide it by 2. The radius is 5, so what we end up with is 25 pi over 2. Good, so what we have now is just 0 plus 25 pi over 2, or final answer, just 25 pi over 2. And that's it. That's what our original integral evaluates to.